button there, and you're welcome to ask a question at any point throughout the presentation, but we will hold off until the end to responding. Any questions that have been subsequently addressed in David's presentation will mark off as being completed. So please feel free just to ask away as the questions pop to your mind. You can also upvote a question asked by someone else to improve its chances of being addressed, because we only have about 15 minutes at the end of the presentation. So without further delay, I'd like to hand over to David now to commence his presentation. Thanks, David. David, you'll just need to turn off your mute.
Pushing the wrong button again. There you go. There should be one of those bins. I think they have them at Rotary. They have a swear bin. We could have a little jar for every time you get caught talking to the muted screen. So good morning, everybody. And today I'd like to take you through the work that's being led by the ESB on the post-2025 NEM market design and the issues that has for the grid. And as we go through, we'll find a number of points where I think it's touches very much on the situation in Western Australia and the issues that are faced there. And that will be a fruitful case for people to ask questions and maybe prompt some discussion later. Just a word on the Energy Security Board for people in Western Australia wouldn't probably be too familiar with it. The Energy Security Board was established by the COAG Energy Council in August 2017, and that was following the report by Dr. Alan Finkel, the chief scientist, who wrote a reform blueprint as to how he was and his team recommended developing the NEM to meet the challenges that we face. The ESB was also set up with a remit to look at the whole of system issues around energy security and reliability, and to drive better outcomes for consumers. The ESB, though, is only a group of modest means. It's Kerry Schott as our chair, myself, and the heads of AEMO, the AER, and the AEMC, and really seeks to pull together the resources of all the energy market bodies and deliver the change program that we need. If we look back at Alan's report, the summary up the front says Australia's electricity system is in transition. There's no going back from the massive industrial, technological and economic changes facing our electricity system. I think that's a very stark statement about how profound the change that we're expecting and we are already starting to experience across the electricity system. The ESB is required to undertake a health of the NEM review each year, and in 2019, at the end of the year, we published the last one, looking at how much we were delivering on affordable energy and satisfied customers, on security, on reliability and emissions, on the effective development of competition, and on getting the efficient and timely investment we need in our networks as they transform. The scorecard there, well, we said that it had improved over the previous year, but that's really the only good news. There were a range of issues that were active that we felt needed to be addressed urgently. And the most concern is really the security of the power system. And the security of the power system is really thinking about its ability to maintain frequency, voltage and stable operation in the face of some disturbances. And that has deteriorated over the last few years and is of course a great concern because a security failure can lead to a cascading failure of the system. Reliability is an issue and it's remained very tight during summer peak demand in the southern states, and we've had some load shedding, and AEMO has had to purchase a range of reserves under the emergency reserve trading schemes. And that's been in part due to the severity of some weather events. And in Victoria, Western Victoria, there was an extremely severe event on the end of January this year, which actually blew over some 500 kV transmission towers. And these absolutely monstrous towers looked a bit like a paperclip that I've finished with after an agitated day. It just twisted and dumped on the ground. So we've faced those. We also are in the stage now where there is a number of coal generators which are getting quite old and are being pushed to drive more variably and are becoming less dependable. Affordability did improve slightly as retail margins tightened with more competition, and wholesale market costs fell, primarily as a result of the amount of renewable generation that's moved into the NEM. So there was a modicum of good news on affordability. New renewable generators, though, are experiencing some quite severe difficulties in getting access to the grid. The grid's getting constrained with too much new generation connected in areas that have got poor network access. The loss factors that apply to these have dropped, which affects their financial viability. And there's a range of technical issues that they're facing in terms of system strength to be able to connect in some of these parts of the grid where there's attractive renewable resources. The integrated system plan has now become a key part of the framework of the NEM and sets out the transmission requirements over the next 2 decades and identifies priority renewable energy zones. And that's an important, I think, move, because we certainly recognise that the network, the whole grid, needs to adapt to the new challenge. And this provides a blueprint to get that to happen. There's new rules even come into force tomorrow to help make that more implementable. And we have had progress, and there's 3 projects that are well underway at the moment, starting to enhance the national grid. Distribution networks are really being challenged in a couple of areas by the rapid uptake of rooftop solar PV. So a bit of a mixed scorecard from the health of the NEM, but nonetheless pointing to the sort of issues about security, about reliability, and about grid access in particular. So what are the technical drivers for that? Well, there has been remarkable growth in variable renewable energy in the NEM. In 2018-19, the last full financial year, 16% of electricity across the whole of the NEM was generated by wind and solar. I understand that figure today is about 20%. And that figure was over half, 53% in South Australia. Now, this is the average energy in a whole year. And when you look at the sort of capacity factor with which wind and solar operates, you can multiply those numbers by 2 or 3 times to look at what the instantaneous rate of those can be on some days. That will continue to rise, and the forecast is on the central forecast is that we'd expect about 27% wind and solar by 2030 and over 40% by 2040. There's also a high and growing proportion of rooftop solar. Certainly that's an issue that Western Australia was very familiar with. Across the whole of the NEM, that's about 5%, just past 5% of NEM generation. And this year I expect it'll be 13% in South Australia. And those numbers are moving up fast. We certainly expect over 10% of all NEM generation to be from rooftop solar before 2030. Inverter connected plant has different technical characteristics, and it leads to a supply mix with a greater proportion of variable, asynchronous, and distributed generation. And those factors are remarkably consistent between Western Australia and the NEM and have a big impact on our outlook. Obviously, though, with different market designs and a different context, they'll sometimes have different impacts and maybe need to be dealt with differently. So the COAG Energy Council has requested the Energy Security Board to advise on the long-term design of the market to meet these challenges. And it's timely that they do that when you think that the basic framework for the NEM has remained relatively unchanged since the market started in 1998. And yet the generation technologies, the pattern of energy use and government energy policies, whole lots of things have changed massively since that time. And we do need to then reassess where the market design should take us. Over the last 10 years, household electricity costs rose by 56% in real terms. And the NEM spot price moved from one end of the scale to the other. In 2012, it was at its bottom. And in 2017, it hit record highs. It's just a little off those highs earlier this year and has dropped a bit further, dropped quite significantly through coronavirus times. And we had an excess of capacity in the early part of that decade, and in the latter part of that decade, reserve margins have tightened and reliability concerns have emerged. So it's fair to say that the market has struggled to meet the expectations of consumers and the community. So it's no wonder that ministers charged us to look at what should be the future market design. Just to outline a few of the specific challenges that we're thinking about. And this is a little patchwork quilt of a lot of work that's going on behind the scenes to understand the issues and think about how we should be looking at the future market needs. So one of the first ones, we talk about missing markets. Now, what we've had in the past with traditional generations, conventional thermal plant, it provides things like inertia, system strength, voltage control, frequency control type services as an adjunct to its normal operation. So we've often talked about that as ancillary services. They come with the device, and a number of those are not paid for in the current market or any market worldwide, to my knowledge. So we need to actually think about market mechanisms that will value and price those. And if that's not addressed, then the issue will become acute over the next 2 decades. Increasing complexity, uncertainty and variability. Well, it's certainly getting much harder to manage a power system when you have such an amount of dynamic behaviour by the utility scale, renewable generators, by the distributed generation, which generally you have much less control and even visibility of. And increasingly, we're going to see batteries, rooftop battery storage. It's not rooftop, wouldn't be a good place to put a battery. Household and business battery storage, as well as utility scale. And all these are adding to the complexity of running and operating the system. And how we actually coordinate the resources to actually minimise cost and maintain system security becomes quite difficult. And that is leading to more directions or more interventions by the market operator. And we certainly don't want to see directions in the sense that directions are a last resort. Otherwise, they're a very inefficient way of doing things. They cost money, but they don't actually provide signals for people to invest and do things to reduce those costs. Without changes, that situation could become quite unmanageable. Managing network constraints, well, you can, if you look at the integrated system plan, the new one's actually out in a few weeks' time, probably early August. But the message is going to be broadly the same, that you'll find that by 2040, you finish up with more around about double the installed capacity that you do today to meet not much greater load. And that's because you have a need for a lot more generation, which has a lower capacity factor. It generates less electricity per megawatt over a year. And you also have a storage requirement. So you finish up having to connect a lot more capacity to the network to meet the same kind of load. And so the network then is going to become more congested at different times of the day, different seasons, as you get excess of solar, excess of wind, generation going to storage and coming out of storage. And that message is also true at the distribution system, where we expect a large amount of distributed resources. And so that will challenge the network there in terms of congestion and potential loadings on the distribution systems. And participants need to be able to manage the associated risks and costs of those network constraints. Now, investment in dispatchable capacity, we'll talk briefly about this one a bit more, because that's an interesting issue between the NEM and the WA market, in that the WA market has a capacity market and the NEM doesn't. But what we find is that there's not really an issue in getting capacity, as I talked about there. We're getting capacity by the bucket load. The concern really is about the future investment drivers for the dispatchable plant, the flexible plant, the fast acting plant that's required to replace coal generation as it requires, and firm the variable renewable energy and provide those other services. So that's talking about pumped hydro, or battery storage, or fast acting generation. There is a little investment in that, and there's quite some interesting investments, including Barker's Inlet in South Australia, where you'll see AGL's invested in a set of generators that can start inside a few minutes, so that it can do that sort of role. And we now have about 800 megawatts of utility scale batteries in the NEM. Nevertheless, that's what our concern is. Is there sufficient investment in those to maintain reliability in the face of a highly variable market? Distributed energy resources, well, they're certainly moving away from being an adjunct and a few people offsetting a bit of their load with some rooftop solar. We're finding it's moving from the residential into the business sector. You're getting a lot reasonable size installations of solar, and now of course batteries are coming into that sort of picture as well. And at the moment, those customers often are unable to effectively respond to price signals, so they're not really able to actually contribute correctly to the rest of the NEM or for their own benefit. So we really need to ensure that customers need to be integrated into the whole supply chain, not just sort of seen as a negative load. And if we can actually get cross-optimization of DER back into the wholesale market, then there's potential system-wide benefits to the network, to spot market and wholesale prices, and even in the supply of some of these essential system services. So that's another major challenge for the design of the market. How do we actually integrate, instead of relatively small numbers of large units, potentially hundreds of thousands or even millions of generators that are in customers' premises? Now, in thinking about our work program, it's about the longer term 2025 project, but we've also got a range of matters that we've already dealt with. I mentioned before the integration of the integrated system plan and a process built off that into the rules. We've got some urgent actions right now to improve reliability, security, and some interim arrangements for access for renewable energy zones. And then we're moving into looking at some intermediate actions to improve the way in which we dispatch plant ahead of time, and the way we involve customers in the market, and looking at access reform as part of that longer term process as well. And I guess it's sort of obvious to say, but you can't really have a theoretical project where we actually devise the ideal market requirements for 2025 and then sit on our hands and do nothing in between. So there is a process whereby we're looking at the evolution of the market, building through to that 2025 design and dealing with issues as they need to be right now. Just to touch on a couple of those areas which I think are very relevant to the power system in Western Australia. We talked about these missing markets. So we need to develop a new framework for valuing and procuring some of these, we like to now call them essential system services, because they aren't just ancillary to the production in a conventional generator. We even need to drive investment in specific plant. Some of the new opportunities and technologies that are coming out there are very promising and offer some real opportunities to keep the costs down and deliver the right sort of reliability and security we're looking for. And we do need to actually manage both the investment and disinvestment cycle as we change the supply stock over, and efficiently utilise the resources that are available in any particular time. So how do we patch all that together? And we're looking at a spectrum of opportunities in terms of adding some additional markets to the existing 8 services that we have in terms of the market services. But then we're also looking at how do we specifically deal with some of these more thorny questions like system strength, for which there isn't a single parameter, or inertia where there is a single parameter, but it's something that's supplied the minute a generator synchronizes with the system. It's not actually a controlled or produced product that you can easily design a spot market around. So really thinking through how we adapt the market over time in terms of a more comprehensive set of markets to drive investment across all those requirements and value all those. And I know there's a major program being on in Western Australia considering the need for ancillary service market changes. Talked before about the adjustments in the resource adequacy mechanisms in the market. Well, how are we thinking about driving investment in this sort of dispatchable capacity? I would say we're looking very deeply at a range of adjustments to the existing NEM, some enhancements in terms of additional price signals into the spot market, to potentially driving additional requirements on parties to contract to cover their exposure, through to various types of markets for capacity that might overlay the NEM. I'd say there, as we look at this, I think the future outlook is also challenging worldwide traditional capacity markets, in that the definition of capacity is nowhere near as clear as it used to be when it was a nameplate number on a conventional generator. And what we're trying to seek to incentivize here is not just megawatts, but it's megawatts of the right character at the right time and the right place. And integrating DER is another area, as we said, is obviously very important in WA as well. And the strong growth in those has been so high that as we go forward, I'm finding that the upper bound of forecast, we have what's called a step change scenario in the forecast AMO producers. And what we have actually seen is that the installation of distributed energy resources hasn't followed the mean or central forecast. It's tended to bounce along right up at the upper bound of those forecasts on that step change option. And there doesn't seem to be any slowing down of that. And that's even more recently through COVID, there's still strong interest by people and companies in producing their own electricity. Now, DER presents both challenges and some real opportunities, and done poorly, it will increase security risks and increase costs in the distribution systems, and that'll actually increase costs down to particular customers who perhaps don't have the means of others. On the other hand, done well, I think it could be a whole new source of flexibility in that we could make the load more flexible. It could supply those essential system services that we need, or at least compete for the supply of some of those with the utility scale. And it could deliver services to the network which actually reduce the cost of operating and developing the distribution network, and thereby benefit all customers. And that's certainly what the ESB is working towards, is how do we make sure that DER provides benefits both to the people that have it and to the system as a whole and all customers. And that's an area where we're sharing information with WA, and it's certainly an area where there's going to be benefits from ongoing sharing of ideas and hopefully sharing of some national technical standards and common approaches like that. Just to swing off the technical angle, you've got to think, well, hang on a second, what are we all doing this all for? And we're doing it for customers. An overarching principle for our work on the 2025 project has to be the national electricity, which is to promote efficient investment in and operation of and use of electricity service for the long-term interests of consumers. We're also trying to keep in mind the COAG Energy Council Strategic Energy Plan, which is delivering more affordable energy and satisfied energy consumers, and the Finkel Review, who wants to make sure that we're rewarding customers who do the right thing. So we've got to swing back and think about, well, what about the centrality of customers as we think through these, I guess, more technical issues I've mentioned today. And thinking about what is in the long-term interest of customers, we've got to think, well, what is the customer of the future going to look like? And what we are seeing is, of course, that customers are becoming more engaged in the market. The digitalisation that's available, the fact that we all have a very powerful computer that sits in the palm of our hand in our pocket. Most people have got Wi-Fi at home. There's lots of opportunities for automation, for communications and for control, which allows distributed resources and different techniques, and the rise of what's often called the prosumer, the customer that actually is also a producer, as well as a user, as well as potentially a profiler of their load. And that, you know, we certainly expect to see to continue to grow. There will be strong growth in solar PV generation, battery storage, electric vehicles. You know, it's difficult to predict how fast they will rise in Australia, but there's no doubt that they're coming, and every major vehicle manufacturer now has electric vehicles firmly in their portfolio. And then those areas are increasingly going to be supplemented with smarter home management systems and so on. Not only is the customer changing, there's a number of parties that realise the customer is changing, and you're getting different business models and different types of service offerings. We're looking at some of the service offerings which actually go well beyond just a retailing of energy, and you may find a stronger growth in whole of home services, where you don't actually just buy electricity, but maybe someone actually services the entire house to make sure that you have all the heating, cooling, gas, electricity, water, whatever that you need. And there are some of those models emerging already in Australia. So one of the key things for us is thinking about how do we develop an appropriate market design for the future that puts the customer at the centre. And one of the aspects of thinking here is thinking about two-sided markets. And traditionally, electricity is one of the few kind of one-sided markets where you tend to think that the demand is fixed, and the operator works very hard to try to find in any point of time the cheapest mix of resources to actually meet that demand. But a two-sided market would actually, as most markets for other commodities are, would take inputs from both the demand and the supply. So you're actually getting customers to choose what they're prepared to pay for how much electricity for what services. And that sort of thinking becomes a more necessary part of how we can better involve DER and customers into the centre of our markets, and how do we think through maximising their participation. Now, that participation could be by the consumer themselves, although I doubt that, and more likely that's through service providers or aggregators who do that on their behalf. And increasingly in the future, I expect also through artificial intelligence. So in that sense, we need to think about how we can evolve the market, thinking about both sides being optimised and thinking about placing obligations on functions and activities rather than particular individual participant categories that we've thought out in the past. And we're looking at ways, as in all these processes, as to how we can progressively implement these things, turn them into a staged process, which could initially be a voluntary type participation. It could then require double-sided markets in larger customers or particular types of customers that have batteries, for example. And then, you could require some form of compulsory participation, albeit with third parties doing that, or potentially default offers from parties who haven't chosen. So the whole area of customers and the interface between the market and customers is also a key part of our thinking for the future market. The design process we're looking at, we've got a number of what we're calling market design initiatives where we're deep diving. It's good that they're coloured blue. They kind of look like a deep swimming pool or something. So we actually have to dive into each of the areas and really understand the issues in each of those areas and bring up options and ways that we could deal with it. But then we have to actually recognise that these don't stand by themselves, and we're trying to come up with a holistic design. And several key options in some areas actually affect solutions in the others. So we look at each of the individual market design initiatives, but also to think about the way in which they might fit or not fit together across those things, and then to establish criteria and filters to assess out of that what are the best candidates. And what we're looking to do is by the end of this year that we'll have 3, say, candidate designs, holistic market designs of options for direction in the development of the NEM. And then that will go to ministers at the end of this year. And then we will undertake a more detailed evaluation amongst those candidate designs for a decision in mid-2021. And that's just shown on that diagram there. So I'll leave it at that and hand back to you, Mena, for any questions that people have.
Thanks a lot, David. That was fantastic. We've got a couple of questions here. I'm just having a look. Some of them are a little bit longer than others. I might start with the most recent one, actually. How does this work intersect with the energy technology roadmap?
Well, the energy technology roadmap is really starting to think about the technologies that can drive us towards achieving the emissions reductions. And I don't think it's in any way inconsistent with it. You'll find that the technologies that are discussed in that roadmap are very much along the lines of the areas that we've looked at. And they, I think, we're in a position now where it's become clear that the cheapest technologies for the generation of electricity now are renewable generation. and the need for storage and firming and transmission. So I think the technology is now becoming an agreed factor, and that's good. The other drivers on how that might actually occur to drive those emissions down, I think, is the missing piece. Still, we're still thinking there obviously still needs some policy development.
Great, thanks for that. Now a question from Mike Reeve. The dispatchable investment component and the essential system services component seem like an odd coupling. The former seems to nominate the types of generators we consider desirable, while the latter seems to focus on quantifiable service metrics and remain agnostic as to the technology delivering the service. Why do both? Why not do one or the other? Should we understand the dispatchable generator investment incentives as insurance because we're not confident of what the combination of energy and ESS markets might deliver?
Yes, well, here we're in a interesting area of defining what's a service and what's energy. So traditionally in the NEM, we've thought about services as things that are delivered inside a dispatch interval. So the stuff that happens inside a 5-minute period. And energy is kind of this megawatt hours, the actual overall delivered product. Well, now what we're sort of thinking about is about the ability of some of the energy to be provided flexibly, to be provided fast. As I'm sure many of my colleagues in WA could tell you, at times you have the wind fall off just as the load rises at the start of a day, so you finish up with quite a steep rise. At the end of the day, you're now getting an effect where the load's still high, but the solar's dropping off. So you have quite a short peak at the end of the day. How do you have those energy supply which can actually achieve those things? It's not very good with a duck curve. Sounds like nice and friendly, cuddly animal, but it's not very cuddly to a coal-fired generator. Is it supposed to stop and start twice a day? Well, it can't do that. So what we're thinking about there is how do you provide the right remuneration and incentive for parties to invest in batteries with the right megawatt hours or fast start generators that can actually do those flexible pieces. And it may or may not be linked to the essential system services. So for example, we need system strength, which is a synchronizing service that needs currently needs a synchronous machine to do that. But you may have very low inertia, or even no, like a battery could actually provide some of that flexible supply. So they're related, but they're not the same. And they are two work streams though that are very closely related. And closely related to that, we've got that work stream thinking about what about the exit of thermal plant. And a big player in the NEM is the fact that we've got some very large coal-fired generators that are getting quite old. And over the next decade to decade and a half, a large number of those are going to retire. And so that will remove a whole lot of conventional generation from the mix, which will mean that we'll lose a lot of those services and an amount of energy. So what's that going to be replaced with, and how do we actually drive the right incentives for the right mix, which is a much more complex mix than we perhaps had in the past to achieve that outcome.
Great, thanks, David. We don't have too much time for questions, but I just want to add one on that note. Generators, traditional generators, are being asked to operate in ways in which they were not envisaged to operate at the time that they connected. And I just wonder what your thoughts were on that from an energy security perspective and also from a generator performance standards perspective. Is there an opportunity to revisit the situation with some of these generators?
Well, we're certainly finding that in the NEM, that obviously that's increasing the cost and putting different loads on these generators, and as you say, that they were designed for. So we're finding a number, particularly the more marginal coal-fired generators, are really trying to look like they're a gas turbine or something, and that is not a sustainable case, and that's why one of our work programs is looking at what are the risks of exit of those generators, and how might they be compensated for the services they do provide, but also how we provide that right incentives for them to be replaced efficiently. So it's what we want to do is, I guess, facilitate, as Alan Finkel said, an orderly transition from one to the other. Certainly there are a lot of concerns with the role that some coal-fired generators are being placed in at the moment. And I think that probably is true in Western Australia as well.
Yeah, yep. Okay, I might just, as the last question, might try and combine a couple here. So there's a couple of questions on the two-sided energy market topic. So do you see more dynamic time of use tariffs in Australia, even down to residential? And the second one there was, does a two-sided market necessarily imply that if customers fail to bid high enough under scarcity conditions, that they'll fail to be dispatched? In effect, would that look like meter-to-meter load shedding?
Well, I guess to answer the second one first, what we're thinking about is, to actually get to that, you really need a widespread adoption of digitalisation. You know, so that's expecting that there's a rollout of smart devices and communication that allows any of those things to happen. So thinking in terms of that sort of end of the spectrum is not next year, it's not 2025, it's further in the future, but what is the direction there? And it is asking you to disclose more about the value of the different services that you get from energy. So I wouldn't be expecting that you're going to put up a price and you turn off your household. That would be silly. But if you've got a battery, you definitely need to see what the prices are there to enable you to actually make a sensible response. I know that we had some load shedding in the NEM a summer about 18 months ago, and at the time we were shedding load, there were also a number of household batteries that were being charged. So the problem there is that they don't see what the cost and value of energy is at that time, and they can't respond. So that's a case of poor integration of DER. So we do have to be able to get price signals through to those parties that need it and that want to participate and engage. Now, exactly how that happens, I think, is a case that we're working on. But yes, we do have to enable that two-way flow so that people can respond to those signals, or some services and some customers. And I might say there are already a range of parties that are now bringing forward new products and discriminated products that help you respond to those sorts of prices, including the South Australian solar sponge, as it's called, tariff, which I like the name of it anyway.
It does have a nice name, doesn't it? So to see it soaking up all of that solar energy.
Yeah.
So we might leave it there. Thank you very much for those people who have asked questions, and apologies if we didn't get to respond to yours. I'd like to thank David for his insights today. It was really a pleasure to hear a bit more about the Energy Security Board and the challenges before the NEM, and it was appreciated that you put a bit of a WA focus in there as well. David, the AIE will be making a donation in your name to a charity of your choice as a thank you for your generosity in sharing your time and knowledge with us. I'd also just like to note that a lot goes into ensuring these events run smoothly, and I'd like to thank Sally Bogle, Cleta Blackerson and Murray Meaton for organising today's event. And a big thank you to everyone also who dialed in, and again, those of you who asked questions. We have a couple of events coming up on the 2nd of July, the Women in Energy Inspiring Leaders series, and on the 7th of July, the Young Energy Professionals have a presentation by Synergy, so please check those out. If you're an AIE member, you would have attended this event for free today. Your membership is now up for renewal, so please, we hope you see the value in renewing your membership again this year. People experiencing financial difficulties due to COVID-19 will also be given consideration to a range of options, including discounts. If you're new to the AIE and would like to join, please go to our website to take a look, to attend more free events and access to things like scholarships and a great, of course, feeling about being a part of this community. All right, thank you very much to everyone who joined, and thanks again, David. It was a pleasure to have you.
Thank you. Thanks, everybody.
See you then. Bye.